Section 10.1. Our objective today is I can define and apply terms related to circles and spheres. So first of all, a circle is defined as the set of all points in a plane at a given distance from a given point is a circle. So the given point is what we call, what we're used to calling the center, and the given distance is what we call the radius. And so if I want all the points 2 units from P, then I just keep locating points in a plane 2 units from P. And if I locate enough of those, it becomes a circle. And so this would be a circle with radius of 2. Okay? And some of the terms that we need to know for a circle. So if I have a circle with center O, then a line segment whose endpoints are on the circle is called a chord. Okay? And a line segment whose points are on the circle but also go through the center is called the diameter. Okay? So a diameter is a chord, but it's a special chord that goes through the center of the circle. Okay? Then the distance from the center of the circle to a point on the circle is called the radius. Okay? And then a line that goes through the circle is called the secant. Notice that the secant contains a chord, but when we're referring to the secant, we're referring to the whole line. And then we have a line that shares only one point with the circle is called a tangent line. And the point that they share is called the point of tangency. Okay? And so when we're talking about a sphere, it's the same idea except for we're talking in space. So a sphere is the set of all points in space. So we're talking three-dimensional at a given distance from a set point. Okay? And so we're talking about in space. So we would be talking a three-dimensional object, where in this case X would be my center, XI would be my radius. Okay? Li would be a diameter. Okay? And if I had where this is G and this is H, I could talk about chord, which would be segment GH, or I could talk about a secant, which would be line GH. So when we're talking about a secant, we're talking about the whole line. When we're talking about a chord, we're just talking about the part whose the segment whose endpoints are on the sphere. Okay. Then we have the idea of congruent circles. and we can have congruent spheres also. And so they are circles or spheres that have congruent radii. Oops. 4. So if the radiuses are congruent, then the circles are congruent. Then we have the idea of concentric circles, okay? And concentric circles are circles in the same plane that have the same center. Okay, so if this is center P, then that would represent concentric circles. And we can also have concentric spheres also, okay? Then we have the idea of an inscribed polygon. The idea of an inscribed polygon is that you already have a circle. And a polygon is placed inside the circle so that each vertex is on the circle. So if I start out with this circle and I want to inscribe a polygon, I construct the polygon so that each vertex touches the circle. Okay, so that would be an inscribed polygon. A circumscribed circle is the idea of you start with a polygon and put a circle about the polygon so that each vertex is on the circle. Okay, so let me go back up here. So the inscribed polygon is that you started with the circle and then you put the polygon inside. Because you already have the circle, you put the polygon inside. In a circumscribed circle, you have the polygon, say we have a triangle, and then you construct the circle around the polygon so that each vertex is tangent or touches the circle. Okay. Then we have the idea of tangent lines. Okay. So remember that a tangent line, we have a circle, and if we have a tangent line and the circle share only one point, point A. Okay? And so we can have what are called externally tangent circles. So for instance, if I have two circles, circle B and circle C, then I can have a tangent line that's tangent to both circles. And we would say these are externally tangent. Okay? Or we could have a tangent line that goes between the circles. And this one would be tangent here and tangent here. And there is an imaginary line that connects the centers. And if a tangent line passes through that that imaginary line, we say that these circles are internally tangent. Or I'm sorry, it's an internal tangent. Okay? Then we can talk about the circles themselves. So we could have a circle and then another circle where the two circles share only one point. So these are internally tangent because one circle is within the other. Or we could have circles like this where they're outside each other but they share one point. And these are called external, the tangent circles. And these are internally tangent circles.